Hello again. In this module, we are going to talk about the dimensional modeling. But before deep dive, I just want to step back and summarize what we have been learned so far. First of all, we have started to get an understanding about OLTP systems, and the main goal in the OLTP systems is the fast write operations. They are not suitable for reporting or complex queries, and OLTP systems mainly employs the entity relationship models that is normalized the 3NF form in order to avoid data redundancy problems. And that necessities lead us to demand of data warehouse which emphasize the fast data retrieval and maintain high performance when handling large and complex queries. Then we discussed about the different data warehouse approaches, which is top-down created by Inman, emphasize the centralized repository and also use entity relationship modeling technique with normalized 3NF form in order to store data in enterprise data warehouses and data marts. And on the other hand, Kimball method, which is also referred as bottom-up, that uses a dimensional model such as star schema or snowflake to organize the data. So today we are going to focus on dimensional model and get a better understanding about the basic fundamentals of it. So first of all, why do we need dimensional model? So as a data engineer, you may know SQL very well and can probably write the SQL queries all day. But for a typical end user, that will be very complex writing SQL queries with the cascading outer joins or some multiple subqueries. So our objective is to build a data warehouse that is so easy for analysts to write queries quickly and effectively. A dimensional model is a data structure technique optimized for data warehousing tools. The main goal of this modeling is to improve the data retrieval, and it is optimized for the select operation. The concept of dimensional modeling is comprised of fact and dimension tables. So facts are the measurements or metrics from your business process. For a sale business process, a measurement will be quarterly sales number or amount or quantity. And dimensions provides the context surrounding a business process event. In simple terms, they give who, what, where of a fact. In the sales business process, for the fact quarterly sales number, dimensions would be who the customer names, where is the location, and what is the product name. In other words, a dimension is a description to provide information about the facts. And the attributes are the various characteristics of the dimension. In the location dimension, the attributes can be state, country, and zip code. So attributes are used to search, filter, or classify the facts. And all these terms are stored in the two types of the tables. The first one is the fact table. So fact table is a primary table in a dimensional model, and in here sales fact is the fact table that is surrounded by relative dimension tables with the foreign key relationship. It includes numerical values of what we measure like amount or quantity. And each fact table includes the keys to associated the dimension tables. These are known as foreign keys in the fact table, and when it is compared to dimension tables, fact tables typically include a small number of columns and have a large number of rows. And the next one is the dimension table. So dimension table offers descriptive characteristics of the facts with the help of their attributes. The dimension attributes are the various columns in a dimension table. So you see in here we have 4 dimension table which include relevant information about product, customer, and sales channel and date. And they are joined to sales fact table via a foreign key. And dimension tables are denormalized tables that can also contain one or more hierarchical relationship. And we need to ensure that dimension tables use surrogate key that we're going to talk about it later. And finally, dimension tables store the history of the dimensional information. And why dimensional modeling is so important? The real strength of dimensional modeling is its ability to be easily understood and used for a wide range of business problems, regardless of an end user's technical knowledge. A carefully designed model saves your analysts, report designers, and data scientists countless of hours. The time saved from cleaning and organizing data allows them to focus on gaining valuable insights. This model is based on the business terms so that the business knows what each fact, dimension, or attribute means. And dimensional models are in denormalized structures, and it means that it has fewer tables and joins, and that provides the optimization for fast data querying. And many relational database platforms recognize this model and optimize query execution plans to get better performance. And on the other hand, dimensional models are adaptable to change to some extent. It's as simple as adding new columns and creating new dimension tables without affecting existing fact table. But it also has challenges when changing granularity of the fact tables. And dimensional model allows easy reporting because it stores data in a way that is easier to retrieve the information from the place it is stored in the database. Information is grouped into clear and simple business categories. And almost any BI tool supports dimensional models. You can use your favorite query tool while someone in the next department accesses the same data with other modeling application. And the last one is dimensional tables store history of dimensional information, and that helps us to get detailed knowledge about the changes took place in the past. Okay, let's do some detailed comparison with dimensional model and 3NF form. So dimensional models are typically type of models that are best suited for OLAP systems or in our data warehouses, and that provides a more simplified structure so that it is more easier for business users to write queries against it. And on the other hand, ER models, which are normalized the 3NF form, emphasize the fast write operations and mainly used in OLTP systems and as well as the inbound data warehouse approach. And dimensional models are also typically in denormalized structure and contain more redundant data to provide a variety of reporting benefits. Typically, several tables from an OLTP will be restructured into a single table in a dimensional model. Therefore, there are usually fewer tables for users so that the less joins will simplify the process of writing queries. And against these, OLTP models are normalized structure which are targeting the fast write operation by reducing data redundancy and keeping one value in the one place. So as we mentioned that due to the denormalized structure of dimensional model, it is designed to read, summarize, analyze the information in a fast response time. In contrast, the relational models are optimized for insertion, updating, and deletion of the data in a real-time online transactional system. And other goal of the dimensional model is the query performance. Since there are fewer tables, there will be fewer joins which gains less processing time and higher performance compared to writing the same query against the OLTP database. So as we mentioned earlier, dimensional model provides a more simplified structure with fewer tables. Therefore, it is more easier for business users to run queries and to practice ad hoc analysis. So in summary, dimensional models are made up of the fact tables based on the business processes and dimensional tables that describe them. So they are designed to be easily joined together and to provide more intuitive data structure for writing queries that have a good performance. So I hope that give you a better idea about dimensional modeling. So thank you for listening.